branch of mathematics concerned with the differentiation and integration of a vector primarily in three-dimensional Euclidean space. The term vector calculus is sometimes used as a synonym for the broader subject of multivariable calculus, which includes vector calculus as well as partial differentiation and multiple integration. It is used extensively in physics and engineering, especially in the description of electromagnetic fields, gravitational fields, and fluid flow. Vector and scalar point function. Point function. A variable quantity whose value at any point depends upon the position of that point in a region of space is known as point function. There are two types of point functions known as vector point function and scalar point function. The definition of vector point function. At each point of p of x, y, z of the region R, there corresponds a vector quantity f bar of x, y, z, then f bar of x, y, z is said to be vector point function. Scalar point function. At each point p of x, y, z of a region R, there corresponds a scalar quantity phi of x, y, z, then phi of x, y, z is said to be a scalar point function. Vector and scalar fields. If a point function defined at each point of a region of space, then that region is called a field. There are two types of field, vector field and scalar field. The definition of vector field. A point function that assigns a vector to each and every point in some region in the space is called a vector field. Example, velocity of flow of a fluid. Scalar field. A point function that assigns a scalar to each and every point in some region in the plane or in space is called a scalar field. Example, potential energy of a particle. Vector differential operator. The operator del is equal to I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z is known as vector differential operator. Vector differential operator is also known as nabla. Here, I bar, j bar, k bar are the unit vectors and delta behaves like an ordinary vector that satisfies all properties of ordinary vectors. Del is equal to I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z. Gradient of a scalar point function. If phi of x geometrical interpretation of gradient. The component of directional derivative del phi in a given direction of a vector a bar is del phi dot a bar by mod a bar. Since del phi dot a bar is equal to del phi into a bar cos theta, where theta is the angle between del phi and a bar, and the maximum value of del phi dot a bar is obtained when cos theta is equal to 1, that implies theta equal to 0, that is when del phi is equal to a bar. The maximum value of del phi dot a bar will be in the direction of del phi itself. Therefore, maximum directional derivative is equal to modulus of del phi. Normal to a surface and angle between two surfaces. Normal to the level surface. If phi of x, y, z is equal to c is a level surface, then the normal to the level surface phi of x, y, z is equal to c is given by grad phi or del phi. Del phi is equal to I dou phi by dou x plus j dou phi by dou y